Pharmaceutical companies often face a trying problem: impurities in their products. Impurities in vaccines can severely impact the safety and viability of the product and can also be difficult to detect. To the consumer, this can mean a lack of trust in the safety of the vaccines they're receiving. The people who identify these impurities and remove them are biological and chemical engineers working at pharmaceutical companies. These engineers and the companies they work for have many issues they must take into consideration when they try to find a solution to this. How much does it cost? How much time will it take to identify these impurities? Companies want a cost-effective product that can be easily implemented, so they can contribute time and money to other needed tasks. They also want accurate outputs, as an inaccurate result could result in impurities in the final product. Ideally, any solution to this issue would also be easy to use, so as not an excessive amount of time taken to train employees in the use of any new technology, and there is a minimized risk of error. For solutions that involve X-ray diffraction, there is a concern about exposure to X-rays and the problems that come with it, so any product involving this would need to minimize X-ray exposure for its operator. In order to provide a solution to these problems, we created VaxClean, a machine which analyzes vaccine samples to find impurities.
The first device is an industrial nebulizer that uses laminar paste technology to convert the solution to a powder. The menu is button and touch controlled and is complete with controls listed. Device is wirelessly connected to alerts and monitors. Laminar paste technology works on low energy and at room temperature. Extremely dry air will pass the solution sample outside of a vapor-permeable membrane. Nebulizer air is fanned onto the vaccine solution, and small vapor droplets run down the column into a filter and collected as powder. Air is recycled and cleaned with the help of activated carbon and silica gel. The second device is powder X-ray diffraction. Results are shown on a wirelessly connected PC. Instructions are compared to an online library and each molecule is identified. A total purity percentage is provided. Once the powder is analyzed, it can be placed back into the solution and the vaccine returns to its initial composition. The mission of VaxClean is to provide an accurate impurity identifier that saves companies money, provides scientists with more time, and instills trust and patience. To make the best product, we kept our customers our priority, and we interviewed Purdue pharmacy students. To prevent electromagnetic radiation, an automatic lock is added that prevents the door from being opened when X-rays are present. Results of the powder sample are improved from a larger X-ray gap and a smaller receiving hole. The process is quicker with a faster scan rate and machine-driven powder packing. Customers can select parts of the technology fit to their needs. The X-ray source can either come from a room temperature or nitrogen. Nitrogen is more expensive, but it drastically improves accuracy. Stakeholders can modify their library database to only include impurities they are looking for. VaxClean requires little training, and vendor assistance as the process is automatic. A special thanks to those who supported and advised the VaxClean prototype. If you want to be known for making clean vaccines, then use VaxClean.